previous video, we finished the chapter Introduction to Human Anatomy and Physiology. In today's video, I will introduce the chemical basis of human anatomy and physiology according to Barron. I will give a brief history and then talk about chemical elements, atoms, molecules, chemical bonds, and water. In 1800, it was discovered that some compounds from the structure of living organisms can be synthesized. In 1828, Friedrich Vochler synthesized urea, which is a degradation product of protein metabolism. Now we will define chemical principles. Chemical elements. All matter in the universe is made up of one or more fundamental components called chemical elements. 92 elements are natural. An element cannot be broken down into simpler components by chemical means. More than 90% of the weight of the human body is made of chemical elements like hydrogen, carbon, oxygen, and nitrogen. It is important for a person in the medical field to know the atomic mass of at least a few elements. I've listed some here. Atoms. They are the fundamental units that make up chemical elements. An atom cannot be broken down into smaller subunits without losing its elementary properties. They are made up of protons, neutrons, which are also called nuclears, and electrons that orbit around the nucleus. The mass of a proton is about 1835 times greater than the mass of an electron. The mass of a proton is equal to the mass of a neutron. If you look in the periodic table, you will be able to see some numbers in each box of the chemical elements. The atomic number is the number of protons. The mass number is the number of protons plus the number of neutrons. This mass is also called the atomic mass. Atoms are more stable when there is a full number of electrons on the outer shell. Helium, neon, and chromium are inert elements because they do not react with other atoms. The number of protons is equal to the number of electrons, so it follows that atoms are electrically neutral. When the number of protons is not equal to the number of electrons, we are dealing with ions. When the number of protons is greater than the number of the electrons, we speak of an ion with a positive charge. When the number of electrons is greater than the number of protons, we speak of an ion with a negative charge. The number of protons is the same for all atoms of an element. The number of neutrons can vary. This is how isotopes appear. They have the same atomic number, but the atomic mass is different. Chemical reactions always involve the exchange of electrons. When a reaction results in the loss of electrons, it is called oxidation. When a reaction results in the gain of electrons, it is called reduction. When these phenomena occur together, an oxidation-reduction reaction occurs. Molecules. Molecules are the basic units of chemical compounds. They are chemical combinations of two or more atoms. If they are made up of several types of atoms, they are called compounds. Examples of compounds are water and carbohydrates. The properties of a molecule is determined by the arrangement of atoms in the molecule. The molecular mass is the sum of the atomic mass of the atoms in the molecule. This is expressed in daltons. 1 dalton is the mass of a hydrogen atom. Chemical bonds. They result from the close proximity of atoms and the overlap of the electronic structures. Chemical bonds can be ionic, covalent, or hydrogen bonds. Ionic bonds are strong and result from the transfer of electrons from one atom to another atom. They determine the presence of electrically charged atoms, which are ions. Ionic bonds result from the fact that ions with opposite charges attract each other. An example of an ionic bond is between sodium and chlorine, forming sodium chloride. Covalent bonding results from two atoms sharing one or more electrons. It is a strong carbon-carbon bond. When a single pair of electrons is shared, a single covalent bond results. When two pairs of electrons are shared, a double bond results. The hydrogen bond is weak. This bond results from attractions between pairs of molecules that are slightly positive or negative. Hydrogen bonding can be found in water, resulting from water cohesion, and is present in the nucleic acids in the maintenance of the double helix structure of DNA. Last but not least, it is important to know that water is the universal solvent in the human body, representing approximately 75% of the body's mass. That being said, we have reached the end of this video. If you liked it, don't forget to hit the like, share, and subscribe button, and comment your thoughts on this video. Have a nice week.